Okay, section 9.3, hyperbolas. You can read at the top, a hyperbola is a set of all points x, y, where the difference of the distance between the foci is constant. So notice difference. So our equation for hyperbola has a minus sign in the middle, right? Ellipse had a plus sign, hyperbola has a minus sign. So obviously the order you add things does not matter. So ellipse, we didn't really care which one was in the front. The order you subtract things is super important. So if the x is the positive one, right? I'm going to say in front, but if we really wanted to mess you up, we could put the negative sign in front, right? But if the x is the positive variable, then it follows the x-axis and it opens sideways, left and right. If the y is the positive variable, normally that means in front, then it follows the y-axis and it opens up and down. We're going to get the rectangle that you see pretty much the same way that we did for ellipse. You're going to be able to really quickly know your center, and then you'll take the square root of the number under the x term, and that'll be your left, right. You'll take the square root of the number under the y term, and that'll be your up, down. And then we'll make a rectangle out of it and some asymptotes. The equation for focus. So I tried to emphasize during the ellipse video that the equation for ellipses had a plus in the middle, and then your focus equation had a minus in the middle. So this is the opposite. The hyperbola equation has a minus in the middle, and your equation for the focus has a plus in the middle because it's further out. So look at your picture. I don't know how much coloring on this is going to help you guys, but notice that you go further than A to find your focus because it's going to be inside the little hyperbolas, but the little cup-shaped figures, your focus is inside of those. So it has to go further than the hyperbola itself. There is also an equation for asymptotes on this page. That is point slope form. It's always easier if you just leave it in that form. So notice I'm talking about these right here, the asymptote equations. They're almost identical, but it depends on where A and B is. Notice in our hyperbola equation, A is always under the first term, the positive term. But if you just pay attention to where Y is, slope is rise over run, right? So whatever number is under Y goes on top of that slope fraction. So in the first example, B is under there, so I square root B squared, I get B. In the second equation, A squared is under Y, so I square root that, and I get A. And then whatever number is under the X, B squared, A squared for the first one, so A, and B squared for the second one, so B. This will be a lot easier when we do one with numbers, but this is the formula page. You guys can look back at this as we go. So, sketch the graph. So we're going to find all these things. We can make some answer blanks if you'd like. You should already be able to tell me the center. It's exactly the same as ellipse and circle. See if you can name the center. We'll talk about the vertices. I didn't talk about them much on the other page. Foci and asymptotes. Hopefully you are filling in the center. Okay, so opposite of x, opposite of y, right, in the parentheses. So x minus 3, so positive 3 for the x value. Y plus 4, so negative 4 for the y value. That's our center. Now just pay attention to where the numbers are. I can't guarantee that these are the same colors I used last video, so. Under the x is a 16. Square root that, 4, and you'll go 4, x is left, right. So 4 to the right, put a point, and 4 to the left. Just like when we were doing ellipse. The number under x tells you left, right. So then the number under the y, 9, Notice it's a perfect square. Square root of 9 is 3. So I'm going to go 3 up, down from the center. That's just like ellipse. But if this was an ellipse, I would connect those and try to make it look like an ellipse, right? But this one's a hyperbola because of the minus sign in the middle. Notice the minus sign. So instead, I'm going to make a dotted rectangle following my graph paper so that it hits those 4 points. Went a little far over here. So the reason I make that rectangle is because I need the corners. And it's perfectly fine with me if you just find the corners without actually drawing the rectangle. So next time maybe I'll just find the corners of what would be that rectangle. Because my asymptotes go straight through opposite corners and the center. Opposite corners and the center. Those are my asymptotes. Now look at the minus sign. Again, I can't guarantee these are the same colors, so the minus is in the middle, so it's the x that's positive. That means my graph is going to follow the x-axis. So my first points that I know for sure are those ones that I made blue a second ago. I'm making them purple now because they were my left-right. My left-right points are correct because this has, what does it say over here? A horizontal transverse, right? Because the x-axis is our horizontal one. Those points we know for sure, and then it slowly comes out and hugs the asymptotes, going on forever, but trying not to touch the asymptotes. This is our hyperbola. Now let's finish answering the questions. So vertices are only the ones that you know it touches, right? So my box had a bunch of points on it. But originally I had 4 points, right? The center and then the 4 points around it. Only those purple points count. So it's on graph paper. You should be able to count out those points. Let's see. 7, -4 is 1. -1, -4 is the other. Then the foci. Now we need our equation. C squared equals A squared plus B squared. Remember, A and B are already squared. It likes you to think of A as being the one under the positive and B being the one under the negative. But because it's plus, it doesn't even technically matter. C squared equals, those are already squared, 16 plus 9. C squared equals 25. C equals 5. So 5 to the right and 5 to the left. So here and here would be my focus. So figure out what those points are. From center is where I went, right? 5 to the left, 5 to the right, because this has a horizontal transverse. So it's going to be 8, -4, and -2, -4. Notice, again, horizontal transverse, every y value has been the same for my answers, because the only thing changing are the x's for all of our important points. Also, I want you to know the c squared equation might not always come out perfectly, so I'm just going to do some work down here in orange. It's not for this problem, right? But what if I got c squared equaled 16 plus 4, so c squared equaled 20, so c equaled square root of 20? Let's just say it was the exact same problem, right? My center was 3, -4, and the only thing I'm changing is my x's, right? Because it's horizontal transverse for this problem. So my focus would look like this: 3 plus or minus root 20, comma, -4. Because I can't actually do that math, but I would go root 20 to the right, which is adding root 20, and then root 20 to the left, which is subtracting root 20, and that's what my answer would look like. But this one worked out. I just wanted to do that as an example. And then lastly, my asymptotes. So you can go back and look at the point slope formula if you're not familiar with it, but it's y minus k. It already says that. Y plus 4 from the equation is already minus k because you did the opposite, equals plus or minus, because there's 2 asymptotes. I'll fill that in a second. And then x minus 3. These pieces came straight from my equation, just as they are. No squareds on them, but just as they are. And then plus or minus my slope. It's rise over run. So under the y value is a 9. Square root of that is 3 over. And then the number under the x value is a 16. Square root of that is 4. I'll highlight these so you know where they came from. This came from the square root, that's the wrong color, square root of 9, the green number. This one came from the square root of 16. But also, you have a picture, right? If you need to, make a slope triangle. You should clearly be able to see that it rised 3 and ran 4. So one of them is uphill, positive 3/4, and the other one is downhill. Don't do anything else with this. Do not distribute the 3/4. Don't move the 4. Just leave it just like this. This is our answer to both asymptotes. Okay, what if it's not given to us in that perfect standard form, right? So similar to ellipses, we want to organize, but we also want to pay attention to the negative sign. So in this problem, here's my negative sign. It's in front of the x. So I want that to be second, because I like my negative sign to be in the middle. So keep the y's, or move the y's together. Move your x's together, and then move the constant to the other side. Then, remember, it has coefficients, right? It's not a circle. There's a 16 that I need to factor out of my y's, so that gets factored out front. Luckily, that's easily divisible by 16. And then I will complete the square. Then for the x's, that negative sign needs to be factored out. And it factors out of both x's. So -1, if you want to write it, but I don't, gets factored out. Divide by a negative, divide by a negative, and now it's minus 2x, and that's the most common mistake. Plus something else, because I'm going to complete that square. It's going to equal -47, but technically I added 16 boxes, and I subtracted one triangle to keep it balanced. So you need to do the exact same thing with the ellipse, but one of them is going to be minus because this is a hyperbola. Okay, see if you can complete the square on this. Pause your video, see if you can get the insides and the shapes. So half of 4 is 2, squared is 4. Half of -2 is -1, squared is 1. -47 plus, this is 64, minus 1 equals 16. But again, this is not in standard form. Standard form is just like an ellipse where it has to equal 1. So we divide by the 16 at the, it's the equal to 1. That's why we're dividing by 16. It's a coincidence that that one's 16 also. That reduces perfectly. I still like to put it over 1 so I know where all my numbers are. This one stays over 16. And now it equals 1. And now you should be able to tell me some things about it. Okay, there's all our answer blanks. So center, hopefully you're getting really good at center, but pay attention to the variables, right? If you wrote down -2, 1, it's wrong. The x variable comes from the x parentheses, so +1, and the y variable comes from the y parentheses. So 1, -2 is our center. Then I look under x. Square root of that is 4, so I'm going to go 4 left and right because it's under the x value. Then I look under y. Square root of 1 is 1, so I'm going to go 1 up and down. Remember, it's a hyperbola, so you could draw your rectangle, or you can just see where your corners of a rectangle would be. Asymptotes go straight through opposite corners and the center. Remembering it's a hyperbola, here's your minus sign. So the positive variable this time, the one in front, is y. Y is your vertical up and down variable. So that means that these two dots are actually vertices, and my hyperbola is going to have a vertical transverse. So see if you can fill in vertices, foci, and asymptotes. So now I know my vertices are 1, -1, and 1, -3. And then my foci equation, c squared equals, it really doesn't matter because we're adding them, but 16 plus 1. Here's one where it does not work out perfectly. So see if you could write your foci correctly. You should already be catching on to which variables, which numbers aren't changing. So the 1 is not changing, and I'm going to take the -2, the y value, and I'm going to add and subtract square root of 17, and that would give me my foci points. Asymptotes, see if you can write the equation of the asymptote. Straight from the equation, y plus 2 equals plus n minus, because there's 2 of them, I'm going to leave that blank, x minus 1, straight from the equation. Slope, rise of a run. The rise is only 1 over, and the run is 4. Okay, so hopefully you're getting better at that and you understand what those answers will look like. Let's do one where we go backwards. So find the equation. I like to draw these. So I'm not even going to put any axes. I've got a point at 6, 3. Well, I guess I'll put some axes since I have this graph paper. But I just want you to know you can do this without graph paper. So I have a point at 2, 3. 1, 3 is something, 6, and 7. Hyperbola, the vertices are the 6 and the 2. So it's basically doing this, right? The foci are always inside a hyperbola. So now we need to find the equation. So first of all, figure out, put your big minus down, right? It's a hyperbola. It has a super important minus sign. Has to equal 1. Based on the fact that we know which way this is opening, which variable should go where? So this is opening left and right, so that's an x transverse, horizontal. So x should be your positive and y should be your negative. Then you should be able to see and or calculate the center. I can see my center is right there at 4, 3. Or I could have just added and divided by 2. Would have given me 4, 3 either way. So put your center back into the equation. If the center is 4, 3, then it's x minus 4, y minus 3. I already have my squareds on there, don't forget those. Then I can see how far left and right it went. From the center, I am 2 left and right. So if I go 2 left and right, remember square that, 4 goes under the x. And I can also see, 1, 2, 3. C is 3. So I know 3 squared has to equal 4 plus b squared, right? Because I already squared the 2. So 9 equals 4 plus b squared. 5 equals b squared. You can square root that, but remember it's b squared that goes under y. So this made my arrow too big. This is literally 5. And if I wanted to make my rectangle, it would have gone square root of 5 up and down from the orange dot. But b squared is the number that goes in the equation. Okay, hopefully that helps you guys with hyperbolas. And remember, they're very much like ellipses, but keep an eye on that negative sign.